Okay, today we're going to start Chapter 11, and Chapter 11 is entitled Spatial Reasoning. Now, what is spatial reasoning? Well, somebody with good spatial reasoning skills they are able to visualize a three-dimensional object, to picture it in their mind and maybe rotate it and what it would look like. Also to draw conclusions about that three-dimensional object, maybe with some limited information. So our first lesson today, lesson 11.1, we're going to talk about some three-dimensional figures. And we're going to just review how we would classify them and some of their properties and so on. So the first thing is that we want to review what the definition is for a face, an edge, and a vertex. So if you have a three-dimensional object, your face is just your flat surface. Your flat surface, which is a polygon. So your face of your object is kind of like the side. So my face here, they have it shaded, this would be a face of my three-dimensional figure. This particular would have 6 faces, 4 going around the edges and then the top and the bottom. My edge, well, my edge is a segment where 2 faces meet. So my segment here, my edge, would be as so. And again, we'd have edges going all around, but also on the top and the bottom, where our faces meet. A vertex, well, we know a vertex kind of is a point where 3 or more faces meet. So here they're showing us an example of a vertex. So our face is a polygon, our edge is a segment, and our vertex is a point. Well, let's take a look at some of the names of our three-dimensional figures. First of all, we could have a prism. And it says, a prism is formed by 2 congruent polygonal faces called bases, connected by faces that are parallelograms. So as you can see here, a prism has 2 bases, a top and a bottom. And sometimes it's hard to tell what the bases would be. The bases are the 2 that are congruent. In a prism, the faces or the sides are always going to be parallelograms. And most of the time, those are going to end up being as rectangles. So you can see I have 2 triangular bases on my prism here, but I have 3 rectangular faces. Our cylinder is defined as being formed by 2 parallel, congruent, circular bases and a curved surface that connects the bases. So my cylinder, we know cylinder as thinking about a Pringles can, a pop can, a coffee can, but our 2 bases, top and bottom, are circles. A pyramid, well, a pyramid is formed by a polygonal base and a triangular faces, and they meet at a common vertex. Well, one key word here, the pyramid or a key thought has 1 base, 1 polygonal base, and the faces are always going to be a triangle. My pyramid always has them come and meet at a common vertex point. Lastly, the cone. The cone is formed by a circular base and a curved surface that connects the base to the vertex. So again, we know for a cone, we only have 1 base. At the top, it says that a cube is a prism with 6 square faces. Other prisms and pyramids are named for the shape of their bases. So when we're trying to decide how we would classify our figures, we need to be able to determine what the shape of their base is. Now, our three-dimensional figures, the family name for these is polyhedrons. Okay, all of these are polyhedrons. Well, you can see at the top here in this row, we have prisms. They're all prisms because they have a top and a bottom. But if we needed to classify them, they would be classified according to their base. This is a triangular prism because the top and the bottom are triangles. Pentagonal because the top and the bottom are pentagon. The second row here, we have all pyramids because you can see all of these pyramids only have one base. But again, that's how we are going to classify them. This base is triangular, whereas this base is rectangular. This base is pentagonal. All of the faces of my pyramids are triangles. So along the sides, I have triangles. Where I go up here, along the sides, I would have rectangles. Looking at example A, I am asked to classify my figure. So because I only have one base and it comes up to a common point, I know this is a pyramid. Now in this case, it's a little hard to tell with my base. I guess I don't know for sure if that is a square or not, because I don't know if these are equal. So I would probably classify that as a rectangular pyramid. If it had the tick marks in there, then I would know that it is a square pyramid. How many faces does this figure have? Well, if we count along the sides, we know we would have the 4 triangles along the sides, but we also have this base at the bottom, and that is considered a face. So 1, 2, 3, 4, plus the bottom, I would have 5 faces. What about the edges? How many edges? Well, sometimes kids like to take a highlighter to mark it so that they are able to keep track. We are looking at basically all of my line segments. I have 1, 2, 3, 4 going around the edges, but I also have 1, 2, 3, 4 going around the bottom. So I guess how many edges do we have total? We're going to have 8. How many vertices does this triangle have? Well, vertices, we're looking at the common point. We have that at the top. So as we look at our vertices, we would have 5. What about the bases? It doesn't ask me about the bases, but I would have 1 rectangular base. Okay, I'm going to remind you about a net. It says a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. To identify a three-dimensional figure from a net, you want to look at the number of faces and the shape of each face. So the net is the flat version of your face, or of your polyhedron, and you're wanting to, I guess, kind of try and fold it up in your mind to see what it would look like. I'm going to give you a second to think about what these would be. In figure A, if I thought about folding along these edges, these triangles along the outside would fold up, and we would actually end up with a triangular pyramid, meaning this here would be my base. As I look at folding along all of those segments here, this would end up folding into a cube. Now, because I don't know exactly if these are squares, I would also take rectangular pyramid, but if it looks here as they're square, we're going to take it as square. And lastly, this one can kind of be a little bit tricky, but I would have one circular base. I would kind of think about this wrapping around that circle, and so in the end, this would fold into a cone. thing that is mentioned is a cross section. A cross section is the intersection of a three-dimensional figure and a plane. It says imagine if you were to slice through your shape and open it up. The intersection is a polygon or a circle. So the cross section is two-dimensional. It's a flat figure. Here I can see that I have a cone and they want to slice this cone vertically. Well, if they're going to slice this cone vertically, the intersection, if we were to open that up, we would see a triangle. Now, had it been cut horizontally, the cross section would have been a circle. So it depends on at which angle you're cutting. As you can see below, as with this diagram of a rectangular or square pyramid, if I cut horizontally, my cross section would be a square. If I change that and I cut it at an angle, I would actually end up with a trapezoid. Or if I cut it vertically, I would end up with a cross section that is a triangle. So it depends on which direction or which way you're cutting. They're going to ask you to think about the cross sections here. Here I have a pentagonal pyramid. Well, my pentagonal pyramid, if I cut this horizontally, I can see that my cross section right in there is simply just going to be a pentagon. Here, if I had to classify this figure, well, this is actually a it is a triangular prism because here is the top triangle and the bottom triangle. A triangular prism. If I slice it as shown, my cross section in there would be this flat surface and we would have a rectangle. Okay, so that completes our review for our three-dimensional figures, and we will pick up next time talking about volume.